Section 9.3, maxima and minima. So now we're going to learn how to find a maximum or a minimum. So we're going to say it's a relative or local maximum if it's the largest point in that area. And similarly, we'll say it's a relative minimum if it's the smallest point in the area. And here's some rough sketches. This would be an example of a relative maximum. This would be an example of a relative minimum. We can see that minimum is definitely the lowest point in that area. So where do these extrema occur? So it will be at a point a comma b, and it will be where the partial at x is equal to 0 and the partial of y is equal to 0. And this a comma b we're going to call the critical point, or points in case there's more than one. So let's go ahead and do an example for that. So my function is 6x squared plus 6y squared plus 6xy plus 36x minus 5. So let's begin by finding our two partial derivatives. Let's start with the partial at x, and here I get 12x. That's going to be a constant, so it will disappear, plus 6y plus 36. Then let's go ahead and find our partial at y. That's a constant, so it will disappear. Then I get 12y plus 6x, and everything else will disappear. So we are then going to set those equal to 0 and solve. Now we're going to see how to use the calculator to help us solve these a little bit more easily. In order to put it in the calculator, though, we're going to need to use a matrix. And the way we want these to set up is we want to have the x first, then the y, and then the constant on the other side. So I am going to need to take a moment and rewrite before I can use a matrix. So again, we're going to use something called a matrix, and this is going to be a 2 by 3 matrix, because we're going to make 2 rows and 3 columns. And we're going to put just those coefficients into our matrix. Do note that that equal sign is implied with that negative 36, so I don't have to change anything there. And that's why I need to make sure I have my problems set up correctly so that I have them correctly here in my matrix. So let's get my calculator out and see how to do this. The matrix menu is right here above that x negative 1. So I'm going to hit second and then x negative 1 to bring up that matrix menu. And I'm going to first start by going to edit. And I'm just going to go ahead and edit matrix A. So let's hit enter. Now the first thing we have to enter are the dimensions. Now I've already got 2 by 3, but if not, I can go ahead and put those in. Then I can see the actual matrix, so this is where I want to put those values. Now I can use the directional buttons to navigate, but if I hit 12 and then enter, it will automatically take me to the next spot, just to make it a little bit easier for me to enter all of these values. And I always encourage students to pause and make sure that you've got all of those values in the correct place before we exit this matrix menu. So I've got them entered. Let's hit second mode to quit. I'm back in my regular window. So now I'm going to go to that matrix menu a second time. Now I'm going to go to the math submenu. Now we're going to have to scroll down a bit. I'm looking for RREF. Be careful, there is something called REF. That is something different. We want RREF. So let's hit enter to select that. And now I'm going to go into the matrix menu one more time and select matrix A. That was the matrix that I just edited. And there's my result. Now we're going to ignore that left-hand side. I am going to look at this rightmost column only. That's my x, and that's my y. So I'm going to interpret that as negative 4, comma 2 as my critical point. Now, this is something we could solve by hand without too much difficulty, but in the next section, we're going to have 3 equations and 3 variables, which is a lot harder to solve by hand. So that's why we're going to practice using the calculator for the matrix now, so that we're comfortable with it when we need it in our next section. Alright, so that is how to find critical points. Again, I take each partial, set it equal to 0, make sure to write it in the correct form here of x, then y, and the number on the right, so I can put it on my matrix and use my calculator to get that result. Alright, so we've found a critical point. Now let's see how we can use it. So what is our test for relative extrema? So, to do this, we're going to find something called the discriminant. And we're going to use a capital D there. And it's fxx times fyy minus fxy quantity squared. So we will have to find those three second-order partial derivatives. We will have a maximum if d is positive and fxx is negative. We will have a minimum if d is still positive, but now my fxx is positive. We will have a saddle point. This is something special that we've not really seen before, if d is negative. There is a fourth case there. We are generally not going to see that case for this particular class. Now example 2 is going to pick up from example 1. So we had that function, and we already found that critical point. Let me repeat my two partial derivatives, since I am going to need them. So we had 12x plus 6y plus 36 for the partial at x, and my partial at y was 12y plus 6x. So to find the discriminant, I need to find three of my second order partials. So let's start with fxx. So I'm starting with this, and my variable now is x, so I get 12. Let's then find fyy. So I'm starting here, and my variable is y, so my result, once again, is 12. And finally, let's find fxy. So I'm starting here, but now my variable is y, and I get a 6. So again, I don't need all four second-order partials, but I do need three of them. All right, so let's go ahead and find the discriminant. So we're going to take fxx times fyy minus fxy quantity squared. Now in our class, we will generally get linears for our first order partials, which means my second order partials will be constants, so I'm not going to have to worry about plugging that number in, because obviously it's not going to change. And here, as I plug that through, I'm not going to bother doing all the number crunching. That is a positive. And just to be thorough here, fxx is also positive. So since d is positive and fxx is positive, I can say that negative 4, 2 is a relative min. And I'm just going to write rel min for short there, since I'm lazy. Now I graphed this function. This is not something we can graph on our calculators, unfortunately, because it's three-dimensional. So I used a special software to get that. So we can hopefully see that down there it does look like a minimum and not a maximum. All right, so that is the type of problem we're going to work. Let's try another example where we're going to put all this together. I've got a quick repeat on the top of how we're going to do all of this. And here's our new function, y squared minus x squared. So let's start with our two partials. So the partial at x is negative 2x. The partial at y is 2y. Now again, I'm going to set each of those equal to 0. But I am going to put some extra zeros in here, just to be clear. So when I make my matrix, this is going to be negative 2, 0, 0, then 0, 2, and 0. So again, I always want it written in that form, because otherwise I'm not going to be able to do my matrix correctly. And let's scooch that up a little bit so you can see my calculator. So let's go to my matrix menu. And once again, let's edit. I've already got my dimensions in. So negative 2, 0, 0, 0, 2, 0. Again, I want to pause and make sure I've got that entered in correctly. So go to second matrix, let's go to math, and I scroll down until I see RREF, and then to the matrix menu one more time, where I'm going to select matrix A, since that's the one I just edited. Now again, the only thing I care about is that rightmost column, so it looks like I get 0, 0. So I'm going to eventually put my answer there. We want to label that as a min, max, or saddle point. I'm not quite ready to label it yet though. Let's find our other partials. So fxx, so I start here, x is my variable, I will get -2. Then I need fyy, I'm going to start here, my variable is y, so I get 2. And finally fxy, I start here, my variable is y, which is not there, so I will get 0. So my discriminant, again there's my formula, is fxx times fyy minus fxy quantity squared. Now once again, I don't care what that number actually is. All I care about is if it's positive or negative. This time I did get negative, so if I check, that means that critical number is a saddle point. Let's go back up here and label that accordingly. Well, if I look at my picture, that does hopefully look like a saddle we might have on a horse. So this point is basically here in the middle, where it's a maximum on one axis and a minimum on another axis. That's why we call it a saddle point. So as you go through the homework, you will find all 3 types of points. So again, we want to make sure we have the critical point and that we correctly label it. If we haven't done both those things, we have not completely answered our question. And that is everything in section 9.3. Again, we will have all linears here once we take our first order partials, so we will be able to use that matrix on our calculator to get the critical